This video is about momentum and impulse. Momentum is an important quantity in physics because when two bodies interact, momentum always seems to be conserved. And what we mean by this is that if two bodies collide, this quantity that we call momentum doesn't seem to change overall. The momentum of a body can be calculated with the equation you can see here. We use the letter P, a lowercase p, for momentum, m for mass, and v for velocity. So the momentum of a body is equal to the mass of a body multiplied by its velocity. The mass of a body is measured in kilograms, and the velocity of a body is measured in meters per second. And as we are multiplying mass by velocity, the unit of momentum is the unit of mass multiplied by the unit of velocity. So that is kilogram meters per second. And it can feel uncomfortable the first time you talk about the unit kilogram meters per second because you're used to saying per between units, but this is correct. Momentum is a vector, which means the direction of the momentum is the same as the direction of the velocity. And usually at GCSE level we talk about forward or backwards momentum and forward or backwards velocity, rather than doing anything too complicated in 2 or 3 dimensions. The equation can be rearranged to make the velocity the subject by dividing through by the mass, or rearranged to make the mass the subject by dividing through by the velocity. And in each case, momentum is on the top of this fraction. If you are given different directions for velocity, such as east or west, then the momentum has the same direction. The momentum of a body can be changed by applying a force. And the change in momentum has another special name called impulse. In mathematics, we often represent a change of a variable using a capital delta, which is this triangle here. So that's what impulse is. Usually, the velocity of the body is what changes when you apply a force, rather than the mass of the body. The mass would be constant. And so we could say the impulse is equal to mass multiplied by a change in velocity. A change in velocity is the final velocity of a body minus the initial velocity of a body. From Newton's second law, we know that force is a rate of impulse. And we can represent that as an equation, as we can see here at the bottom of the screen. The impulse divided by the duration that a force is applied for is equal to that force. And so if we have a look at the units, the impulse, measured in kilogram meters per second, because it's a change in momentum, divided by the duration that a force is applied in seconds, is equal to the force. And I've written the units here as kilogram meters per square second, but that is equivalent to the force measured in newtons. And we can rearrange this equation to show that the impulse on a body, the change in momentum of the body, is equal to the force that you apply multiplied by how long you apply that force. In fact, we can substitute for impulse with this expression for impulse, mass multiplied by change in velocity, for a situation where the mass doesn't change. And by doing so, we get an equation that the force is equal to a mass multiplied by a change of velocity divided by a time it takes for the velocity to change. And there's another name for that. That's called acceleration. And so we can get back to our expression that we're familiar with for Newton's second law, F equals ma. Now I know that can be daunting because it looked like there were a lot of equations then. But in fact it can be broken down into just these 4 and rearrangements of them. The definition of momentum, the definition of impulse, a second definition of impulse, and finally our familiar Newton's second law. And all of the questions in chapter 19 can be answered using these 4 equations, or rearranging them and combining these 4 equations. I should add at this point that when we mention the force, we are talking about the resultant force on a body, producing a resultant acceleration, or an overall change of momentum of the body, impulse. Let's have a look at an example question. Let's suppose we have a table of variables like this, and we have some unknowns that we wish to calculate. To calculate A, we can see that we have been given a force and a time, so we're probably going to be using this equation here. We have been given a mass and an initial velocity, but no final velocity. So we're probably going to be looking for a change in momentum equaling a mass times a change in velocity. And we can put those two equations together. If Ft equals delta p and m delta v equals delta p, then Ft equals m delta v. Delta v, remember, was the change in velocity, which is going to be the final velocity minus the initial velocity. We are asked for the velocity afterwards, the final velocity, which is v. So we have to make that the subject. At GCSE level, I would encourage you to work with numbers rather than symbols to start with. So let's substitute our numbers for force, 4.2 newtons. This is multiplied by our time, 12 seconds. And so this part is equal to this part. Our mass is 2.5 kilograms multiplied by the final velocity, which we don't know, minus the initial velocity, which is 0. We can now rearrange the equation to make the final velocity our subject, and then plug this into our calculator, get our answer, and check that it's correct from Isaac Physics.